Welcome, everybody. Thank you for taking the time for this webinar on our Embedded Academy. We'll look into some introduction, like some general topics, and then we'll have the overview and the concept in detail. I'll start with introducing myself a little bit and the company. So my name is Annette Kempf, and I'm the CEO and founder of Eclipseina. And Eclipseina is the company behind the brand Embedded Academy. Embedded Academy, our target with the Embedded Academy is to give you, as the customer, all the know-how you need for successful product development. So to speed up the ramp up of new employees and so on, to have a focus on your core business, the product development, and not being a teaching company. The Embedded Academy provides competencies needed for electronics, electrical engineering, e-mobility, embedded systems, and software development. Just a short look also into the company. So Eclipseina was founded in 2013, so it's 10 years, yeah, and has since then supported the customers with different aspects of embedded development. So we've been training, we have provided e-learning, consulting, but also solutions on charging communication and charging test systems. Our location is in Nittendorf, which is close to Regensburg, so it's just some kilometers, and you can go by bicycle, train, and so on. So more or less, from looking from further away, it's Regensburg. And our products are a software library called EasyLib, the charge controller for charging stations, EasyCharge, and charging test systems. But today we'll look into the Embedded Academy. And what's the agenda? First of all, to look at the motivation. Why did we start the Embedded Academy and what's the target behind? And then the next step will be overall concept. And then we look into the e-learnings in more detail. And then we go back to a website level on a navigation point of view. The initial target or aim was to support these transformation processes, because there's a lot ongoing and the embedded domain is growing very fast and has been growing also in recent years. And there are some major fields and of course a lot of other fields where embedded systems are used as well. As I'm coming from automotive then and have experience in electromobility and also in autonomous driving where I supported projects, this is like the logic part that we look into this. But there's more, especially electromobility is not just vehicle like it was for the combustion engine, but the connection with charging communication, storage systems, and so on is going towards decentralized energy supply. And in general, this decentralized energy supply also needs a lot more in terms of embedded systems, because you have more devices with reduced complexity in comparison to power plants, but it's very diverse and there are lots of solutions. And then, of course, there's this digitalization in other areas, medical, also some smart devices in the consumer products and smart city, for example, trash cans which monitor their filling level, and the route planning of the garbage collectors can be adjusted depending on this. All these things are done in terms of smart city. And then, of course, you need sensors and devices there. And the same is for internet-connected production, because there you have lots more sensors and data transmitted via some bus protocols, field buses. So this is, of course, a huge field, and step by step we are filling these core know-how topics you need. So the idea is, if you work in these transformation fields, you have, for one thing, highest requirements for personnel, and there is always not enough personnel, and you need the solid fundamentals, you need the contemporary know-how, and in some areas also newest technologies or newest standards are of interest. The other motivation was to look at the whole work life, and not just like one aspect, and to say, okay, who needs what during which time. We'll go into some of the aspects also in terms of example projects. But what you have, for example, coming with a university degree. In mechanical engineering, you have other curriculum than in electronical engineering, and many people also come from physics or mathematics and computer science, because it's like a cross-functional thing, the embedded domain. And so it's not like I'm studying to become an embedded engineer. And even if I would study to become an embedded engineer, then I would need to study embedded engineer for automotive, embedded engineer for medical, embedded engineer for whatever. Certain, even some basic things, some curricula do not cover. For example, pulse width modulation, which is like basics even for an electrician and for electronical engineers, most likely in mechanical engineering and physics and mathematics, and in computer science you won't learn it. Yeah, and these are little aspects, and especially in embedded, you really need some basics in electronics and electrical engineering, which is only covered in electronics and electrical engineering studies. So this is one aspect, bringing new employees up to speed. This after studying. Then later on in your work life, there will be lots of changes. And if you look at the whole work life, maybe it's 45 years, maybe with people growing older, it will be even 50 years. And this is a very, very long period of time. So people who are retiring today started even without mobile phones, even without internet, yeah, when they started their work life. And of course, there are lots of changes during this time. So there are new products, new projects, new standards. You need to change your job. For example, you have all the combustion engine people who had more focus on mechanical engineering stuff, which was very important 10 years, 15 years ago, and now it's needed less and less, but you have new requirements and they need to learn the things which are required now to continue their work life. So this is providing with contemporary know-how for job rotation, new projects, technology change. And the third aspect we've been given us was the topic of enable knowledge update. And most people are very reluctant to admit that they forgot something. I'm more relaxed because I finished best in class electronics and electrical engineering studies. And I know I knew a lot more than most of the people who studied with me. And I forgot also a lot. So I've been working in combustion engine, coming back to e-mobility. I had to look up a lot of things on electrical machines, control of electrical machines, and so on. And I think it's normal, and it's necessary to admit that you might not know, like 20 years later, what you've been learning for some exams at the university. So these are the three aspects we've been looking at. And for some of this, we did already projects where I would like to explain a little bit on how these projects were composed. So, but looking first also into the market, why is it necessary, and also why is it necessary, especially to do this onboarding maybe also have some people who are coming from a different field, making them able to work in electronical engineering field. For embedded systems, the market has been growing worldwide by 12% every year as an average for the last 20 years. Yeah? And over the past 25 years, the demand for personnel in this area has increased tenfold or even more than tenfold. So it's like a huge increase of needed personnel. And this is a picture of an article. It's a newspaper article, and it's in German. And it's kind of strange to say Germany needs 11,000 electrical engineers from other countries, it says, from abroad. Yeah. But further down in the article, it's explained that also in all Europe, in the US, in China, in Russia, in Singapore, and in some other places, electrical engineers are also missing. And IT computer scientists who are working in embedded area are also missing. Yeah. And this article also states that in Germany, the gap will grow an estimated 7,800 engineers per year. So we are close to 20,000 now for a gap. And then it makes maybe also sense for project management or for quality engineers to look at people who not studied electrical engineering or computer science, but might fill the positions nevertheless. Yeah. And another aspect I've experienced in practice, I've been in escalated projects supporting different companies. It's this: if you have a quote, you get a quote, you're supposed to quote the project, and if you do not estimate your costs correctly, this will hurt a lot, because then you pay a lot more for your engineering workforce than the customer will ever pay for the project. And I saw this happening more than once. So it's a critical area. And then people need to have ad hoc know-how. So they don't need to plan to talk to their manager and say, I need a training in half a year on this and that topic. They need to be able to search and to find something and to get a rough estimate what it means to work in this area. Yeah. If you're working in this project, if you get the input, you have to be very fast, and you have to be good and fast in the quote, and also when you start the project. So these are the day-to-day challenges in engineering, which I think most of you also experienced already in the past. So what's our vision behind? We want a successful technology change. We want to support it by contemporary topics, efficient knowledge management, on-demand solutions, and also a problem-centered education. In engineering, you cannot learn everything you might ever need, because then you would go to university until you're 55. Yeah, you have to focus on what are your challenges right now, what's the field you're working in, and then you need on-demand and problem-centered education, which is giving you what you need now. This is what I mentioned before, the transformation process of these projects we did. So this one project, I want to just show you what the concepts are behind and what we did there. It's a transformation process with a major personal growth, not the normal growth, but like a really ramping up of an organization. And there, lots of young people were hired, which do not have working experience, and how to bring them up to speed. So addressing this topic had several steps. And the first most important step is to understand you have a personal ramp-up plan. You know who will be hired for which positions, what they are supposed to do. And this onboarding concept and hiring ramp-up plan was done together with between HR and the R&D organization, so that it was clear when will the people be hired, when do we need to have an onboard training, and which people are coming when. The internal training plan was done, so it was a systematic onboarding with trainings within the organization. So these were like also classroom trainings and dedicated exercises so that they get the experience on what the job means and what are the different tasks and like what are the specificities. And it was an artificial kind of project because otherwise you encounter the things maybe in 1 year or 2 years the first time, and this way you go through all these critical steps in a like a small play project. And this was supported in addition by the existing e-learning portfolio. So to say, okay, before they had this systematic testing and so on, and the classroom trainings, so the e-learnings and the classroom trainings were going hand in hand. Where e-learning was possible, e-learning was done, and the rest was done in classroom trainings. And also there were on-site trainings where external trainers came for the typical things. It's an automotive project for the typical things you need to know in automotive. This means requirements engineering, software architecture, and certified tester. And I would always recommend, really always recommend, if you are in embedded system or software development, to have architecture training, even for the young people. This does not mean that they are becoming architect. They will never become like a software architect within 2 or 3 days. It takes a long time with all the experience, but it's essential and very important to have a rough understanding what architecture means, what are the key aspects, and so on. So this is something I really always recommend. Looking at this project, the ramp-up was successful, and through this systematic onboarding and the alignment of the concepts, the young people learned a lot faster, and learning a lot faster means that they are faster productive in the projects. And this is not the only aspect. If they are well trained, this means also that they do less mistakes. And if in embedded, if you make a mistake and you don't find it for a long period of time, and then the costs can be huge. So ensuring that they know what they are doing right from the beginning, and that they don't get used to just doing some stuff, not feeling responsible and not knowing really what they do. Because if you once get used to not knowing what to do, what you're really doing, and still working there, then you will do it for the next years. And if the emphasis is in the beginning on you have to know exactly what you're doing. You have to understand what you're doing. Then the quality and the problems in the projects are a lot less. So this, I would say, was very successful, and also for the company who introduced this. The second aspect is that we work together with one major tier one. It's the transformation from ICE, internal combustion engine, towards e-mobility. And there are a lot of people who worked in combustion engine area. So, and combustion engine software development has been growing. And the solutions have been growing with new legislations and so on. So it's for all the suppliers, it's more or less an old product line, which has been growing. And people who work in this area have been growing into this existing software, like a city which is growing where you never saw a map, but you know where you are going through, and you know exactly the city, like the tasks are clearly defined, and you know which components are needed for a combustion engine, like mass airflow sensor, EGR valve, and so on. You just know the stuff, you know the abbreviations, you know the structure, and now you have to change to e-mobility. And this project was to change from combustion engine development to e-mobility development, not reading something about it, but developing the new products in this field. So you need deep knowledge. And there also we started with a concept development. We did joint workshops between Eclipseina and this international tier one, with whom we've been doing this project, and involved were HR, training organization, and the technical experts. So three different organizational fields, and also with a technical expert, it was widespread. We did not like huge workshops, so we broke down the system, and these workshops were with dedicated technical experts in their field. So we did several workshops, and in addition to these several iterations, to have a training landscape. So we developed a joint concept with a training landscape, and also with certain levels, like an overview level, then a first level and a second level. And in the implementation, we as Eclipseina were able to provide some of the e-learnings in the portfolio which existed already into the learning management landscape, but we've been creating together common e-learning units. And these e-learning units are now used for this tier one, for the internal training from combustion engine to e-mobility to electrified powertrain. And we as Eclipseina were allowed to include these kind of trainings into our embedded academy portfolio. So this was this part, but then it's not everything, because we defined these different levels. And of course, international player, tier one with very deep knowledge, they have their specific solutions, which then needs also adaptations and improvements where they want to train their people on. But this is confidential know-how. So this is not possible to give it to the outside. Within this project, we've been doing some of these e-learning units. These were specific confidential e-learning units, which then, of course, are only used at the tier one, and we were not allowed and able to include them into the portfolio. But nevertheless, we did a big chunk together. What was the result? For us, it was great because we've been increasing the portfolio and can offer a lot on the market now. And for this tier 1, it was a successful transformation process from combustion engine to electrified powertrain development. And they recently won quite a lot of new projects where I'm happy about because they're really successful. And this is what we want to have, successful customers. So now this was like the motivation and the projects and the targets. And now we'll have a look at the overall concept, how they are designed, what's the background, and then next we go more into e-learning in detail. So what we are providing, and parts of this has been discussed right now, is we want to support the transformation. So the how-to, and the transformation is necessary due to new strategies, aligned technical roadmaps, and this needs to be aligned and the personnel needs to be trained in the right direction. And this is supported by 4 different areas. It's personal development in line with the technical roadmap. It's presence and in-house trainings, it's online trainings, videos, e-learning, and it's development of specific, most of the time, confidential training material. And these 4 areas are also represented in the portfolio. So in the consulting, we can support with more than 20 years of management experience in engineering and in training management, automotive industry, so in different fields. We have right now 43 different trainings in embedded and especially in charging and charging communication. We are experts, so these trainings are also going very deep. We have e-learnings right now in the current web shop. We've been designing the web shop completely new, and it will be launched next week. So right now, and we have some new e-learnings prepared, which will be released then soon after the new web shop is online. But right now released are 77 e-learning units with a training material, which is representing more than 15,000 minutes of study time. This is more than 6 weeks. So it's quite a big portfolio already. And of course, we have a service to do e-learning videos, PowerPoints, manuals, and this we did for OEMs, tier 1, tool producers, chip producers. So in different areas, we've been supporting customers with their own material, which is unfortunately not part of the Embedded Academy then. How do we work? This is also from an introduction or from a conceptual point of view, it's important. We have quite a lot of technical know-how, but of course this by far would not be sufficient. And as I said, we had this one project with a major tier 1 where we designed things together, but these are not the only experts. We have a huge network of experts. We work together. And why do we need the experts? They bring in material, they help us in the didactics. And very important is also once it's finished, they do a very critical review to say everything which is inside has to be correct. And this quality step we really need. So this is the network of experts. We have many, many years of knowledge management experience. So I've been setting up a wiki together with some former colleagues now 23 years ago. So it's quite a while of experience. And ever since I used knowledge management systems, so structuring the content and everything, you will find the first things inside the Embedded Academy, but there's a lot more planned, and there is supposed to be a lot more coming up. But we have the first things inside. Yeah, we are able to do creation of digital training material, meaning e-learning. And working with this storyline articulate with professional offering tools, but we can do also videos, animation, 3D animation, and so on. And we are able to do training concepts like the didactics, breaking it down to the details, structuring, giving background information, and so on. Yeah. So now we're coming to the e-learnings themselves. In the e-learnings, first of all, the quality standard we've given us, so to say, these 5 aspects we always focus on. One is which area of topics we are choosing. For example, with e-mobility, electronics, embedded, which topics we're choosing. This is a combination out of what the market needs, where we have experience, and most important, the feedback of customers, what they would like to have next. We are making sure that we always have an expert knowledge, so the content is correct, that you can rely on what you learn there, and it's digital, so it's comparable, that we have correct content. And I think this is in terms of correctness, it's a different level to classroom trainings, because then sometimes you say something wrong, but nobody is able to prove it. For us, it's written or it's recorded, then it's clear. This is the content, and of course we're happy to also get some customer feedback. Yeah? The learning processes, so we have a uniform concept, we have a clear structure, also we are improving the guidelines step by step, and the concept is getting more and more very stable to say, okay, this is the framework we're working on in terms of structure. We have defined symbols we always use, and we also have a fixed color concept behind, which you might not see immediately, but this is also giving some help and navigation if you do more e-learnings, because then you know this color has this content. Then if the didactics, to have a structured didactics to how to break down the information, and also on how to work with the different possibilities you have, like animation or interaction and so on, so that this is part of a didactics. And then we have design and animation. So we even have a designer in the company who won prizes already to have catchy representation, because this is helping you to learn fast. And this is an old slide, but I still like it. And it's so old that we only did it in German. It's the bringing this together, the technical know-how, the didactics, and the design, to have different capabilities and different people with different background in study and experience. And only by combining this, you will get the very good results. And this means also that each single person who is working on creating this e-learning content, they would not be able to do everything in just one person. We need the combination on this diverse team, which is working on the topics. This is last aspects on how to focus on the learning concepts within the e-learnings. This is the concept according to Vesta. it's called, yeah, and Wester defined learning types. And in this definition, it's like one person just learns this way and the other person just learns this way. But of course, it's not like this, but you have people who have more of a tendency to learn one way or the other. And the different types of learning are cognitive learning. So it's learning via intellect, your brain, yeah. You have a visual learning, to say you have to see it. You have auditory learning, so you have to hear it. And you have the haptic learning, where you have to feel the things and touch them and to really work with the things. Yeah? And we looked at the different topics. I address different topics to the different learning types, but of course it's also not matching one-to-one. But from the intellect, we are requesting quite a lot of intellect in the engineering anyway, because the technical content, most of the technical content, especially in electrical engineering and in software development, it's for the intellect. And for these people, usually written text is also for the intellect to read, to do this. For the eyes, I would say to have it visualized, visual learning. It's even if we do animations and it's visualized, there's still part of intellect needed. So you have animations, you have pictures, and I think it's for the technical content, it's very, very important to see the pictures. So we take this into account. Then you have auditory learning. We always have speaker text. We have lots of explanations, which is also a lot more than the written text you can see. And of course, this is often aligned. So you have animation, you have written text and speaker text, and our audience mainly, I would say, is looking at the animations and the pictures and listening to the text. And then the haptic learning is the most difficult, yeah, because there's not really some material or whatever to touch, but at least we wanted to have a little bit of interaction and the body included in this learning process. So we have exercises, for example, with drag and drop and so on. We have a classical interactions where you click something and then you get the speaker text, and we have a quizzes, which of course are exercise and a lot for the intellect too. But this is what we looked at to say, okay, these 4 learning types, are we addressing them in the training in every area enough, so that we support each learning time as good as possible. Yeah. Then this is a picture on the symbols. Yeah. So we have always the same symbols, which we are using to explain the things. Like the first one is attention, like pay attention here and there, summary, and at the end you have always the quiz. And what we do with the symbols, there are, you see in the next picture, they are always in the right corner below. And if you click on the symbol, you get explained what the symbol means or what you need to do. In this picture, you see the animations. This example you even can see on YouTube or in the free glossary on our webpage. So on YouTube, we filmed the e-learning, which then has not all aspects for the training types anymore. And in the free glossary, you will see a unit on PWM signal. And this is what this picture shows. And for example, here, when you then click, this is interaction on frequency, then you will get the written the speaker text, so you will get the explanation what's behind, and at the same time the picture where you see the PWM signal, it's changing the frequency. So you really see the frequency change, which looks like a mundharmonica. I don't know how in English, where it's broader and smaller. And with this, you immediately see what is meant by it. So this is the animation. And for the interaction, this is the typical things that you click something. So if this is an example on EV charging, the different charging modes, and if you have the first page at the beginning, then you only see the 4 modes and no text. And then you can click on each mode, and then the text appears, and you will hear the speaker text. So step by step. And this also means that it's not someone who's telling you mode 1, next mode 2, mode 3, mode 4, and you think, oh, this was too fast. It's always a break in between. You digest, then you click the next one. And this is essential for learning. So it's not only to get the text, also the breaks are very important for learning. So this is the interactions. And then each unit is ending with a quiz. It's not difficult, the quiz. So it's not an exam. It's more or less, did you listen? Can you remember what you learned there? Yeah. So this is like the conceptual structure we have. And then I would like to go as last step into the navigation, because we're getting more and more content, and then it's important to find the things and to navigate through. On the first page, you with the e-learning portfolio, it's not the first page of the website, but when you click on portfolio, you have buttons on the top, and then you can select a field. So here in this example, e-mobility is selected. And then you don't have all the courses. You only have the courses which are connected to e-mobility. And then it's easier to find your way around. And how do we structure the next levels? So this first level we saw in the picture before, the categories. And as our portfolio is now growing and growing and growing and very fast, we might make 2 hierarchies in the categories, but nevertheless, I think it will be still easy to find, so that you select a core subject and maybe then a subject below. And then you have the courses. And the courses themselves are also structured into several parts. And this structuring, you see the number on the left, these 2 to 7. We've been using a rule which is coming from software architecture. And in software architecture, you should never have more than 7, because then it's difficult for the brain to take in. And 1 is not desirable, so it should be 2 to 7. And 4 more or less is the ideal number. Yeah? And you have then the course. On the course level, this is the level where you get the certificate. So if you finish a course, then you get the certificate of completion on the course level. And each course contains 2 to 7 e-learning units. And these e-learning units, again, have different chapters. And the chapter level is the e-learning file. With the offering tools, you have files which you are handling, like in software development as well. And then you get 1 learning file. For example, in SCORM format is a typical format. So this is the chapter level, and usually, except the introduction chapters, for each chapter we have then also a quiz. So these are the different levels which we are building together with the e-learnings, and to ensure that you have a navigation to find your way around. And for example, we are also able to, within one e-learning, to reference a chapter from another e-learning if this is providing background know-how, which some people, for example, the computer science or mathematics or physics, people need this background know-how and the electronical engineers know, or the other way around, then we can reference to another chapter. And this is important to have a learning workflow and to have all the extra information which you as a person need. Yeah? So this was all the e-learnings. And in addition to the e-learnings, like I mentioned before, for PWM, we have a glossary, which currently is still for free. It might become behind the paywall in mid of the year, because we are going to add quite a lot of new glossary units. Right now, I think we have 14 units, which you find on the also on the web page under glossary. And we have a list of abbreviations. So all the abbreviations which are used in different e-learnings are also summarized in a list. So we can both reference abbreviations and glossary units from different e-learnings. So this was the concept, and this is more or less our big question to everybody outside. The world is changing. Is your engineering team ready to do the development for the future? So this would be all from my side. Are there any questions? So nothing in the chat. Here is the contact information. Of course, it's not my email directly. You can mail us at info@eclipseina.com or at training@eclipseina.com. And if you have questions, if you want to have a deeper look into some of the topics, it's no problem to schedule a meeting with us. We also have, this is not the first live event we did. We also have other ones, which is called best practice, how global players train their engineering workforce. And I will have a short break only in 15 minutes. There will be another one where we will look into some of the e-learning content to say, okay, what is really the product portfolio? What is the content? How does it look like? This will be starting in 15 minutes. And of course, we will provide all this also in the long run on YouTube. So if you missed it or missed of some of the other events, you can still get back to us at YouTube under streams and to find the recordings. Thank you very much for your time, and I hope to see you in 15 minutes again. Okay. If not, I wish you a very wonderful weekend. In Germany, we have snow. I don't know how it looks somewhere else, but we have beautiful winter landscape right now. Okay, thank you, and hope to see you soon. Bye-bye.